event. So let us dedicate our prayers to Ma Saraswati. मैं हो जाऊँ अभी से join Well, may the goddess of knowledge bless us with more success. I now request our Honorable Director, Dr. Maya Garg, to acknowledge the presence of delegates and deliver a welcome address to all the intellectuals who have accepted our invitation to be a part of this elite event. So please. Well, all the delegates, I really regret because our director sir is trying to join, but due to some technical issue, he is not able to join. So I would really request you all to bear with us for a few seconds. Yeah, so am I audible to all? I would really request all the participants to acknowledge me if I'm audible to all.
Yes.
Yeah, sir, we really regret because there is some technical error and most of the participants don't have access. So I really regret, but can you all bear with us for 5 minutes? So can you all bear with us for 5 minutes only? There is some
Yeah,
problem. Yeah, thank you so much. Well, sir, I would like to have a short conversation as I really regret that we could not conduct it physically due to the pandemic. So, how has been your experiences?
सर मेरी वॉइस नहीं आ रही है मैंने ज्वाइन तो करा
सर आप
यूट्यूब पे अपना कुछ दे रखा है इसलिए
यूट्यूब पे
दे रखा है
यूट्यूब पे लेकिन सर दिखाई नहीं दे रहे ना मैं तभी तो
आपने एक्सेस नहीं दिया है ना किसी
Well,
को
our director,
तो
sir,
ये नहीं दिखाई दे
would
रही
shortly join us.
सर 1 मिनट दिखाई नहीं दे
I
रहा
am just going to take a 5-minute break.
मुझे नहीं आता है
हाँ सर 1 मिनट सर प्लीज
मैं क्या करूं
सर एक बार यहाँ पे देखना मेरे उसमें
सर मेरे को नहीं आता है Hello, good morning. Are you getting my voice?
Yes.
Hi. Good morning, ladies and gentlemen, and my dear colleagues. I am pleased to welcome our 8 speakers as chief guest of honor, and keynote speakers on this great occasion of 8th International Conference of Advanced Mechanical Engineering Research and Innovation. We are very thankful to all for accepting our invitation and becoming a part of this event. I convey my sincere thanks and welcome our eminent keynote speakers, Dr. Sanjay Kumar Mishra, Chief Guest, Head and Advisor GST, Dr. S.K. Vashni, Head and Advisor DST, Professor R.K. Pandey, IIT Delhi, Professor S.C. Lim, Busan National University, South Korea, Shri Pradeep Chaturvedi, Chairman Quality Council of India, Dr. Rajiv Sharma, Head and Advisor DST, Dr. M.K. Pataria, Head and Advisor DST, Dr. Ramveer, Head and Advisor DST. It is a great pleasure for us to have 8 great personalities here at MIT platform on this international conference organized by Department of Mechanical Engineering. We are honored by your presence here at MIT and thank you for sparing your valuable time for us. We welcome all of you and express our sincere gratitude for accepting our invitation and sparing your valuable experience and knowledge. Your thoughts will give us deep insight for future research and innovation. Your idea will allow us to fill the gap between academic approach and the industry. I also want to express my appreciation to our chairman, Shri Vishnu Sharanji, and vice chairman, Shri Puneet Agarwalji, for this continuous support and quick decision for implementing new ideas. I always appreciate their commitment and deep focus on providing quality education and support for resourceful career building of the students. I feel immense pleasure to welcome all the delegates who have to present their research ideas. You all Sharing your innovative ideas will make this platform a wonderful. Today, we will all have an opportunity to hear from many learned people. The technology advancements are reshaping the entire world at a very fast rate. The technological development in machine learning and artificial intelligence are making every business data driven and smarter. A set of data nowadays is equivalent to a set of knowledge, decision making, and forecasting tool. The more we are recording the data, we are becoming more intelligent through machine learning and artificial intelligence. Things are becoming intelligent, capable of enough to interact smartly with people and environment. The fusion of AI and IoT is innovating new technology for future machines, smart home and cities. Their importance can be seen with their application in business and society. I sometimes question the growth as helpful or harmful. Because these areas are still not fully explored, a lot of work needs to be done. This opens opportunity for research and development. As we all understand the need of the industry, requirement of the society, and development of in technology is changing at a rapid pace. The traditional teaching and learning pedagogy will not support to meet the present upcoming challenges. There is need for paradigm shift in the process of learning. Innovation today are very fast and multidisciplinary. An engineer should have multidisciplinary skills sets along with the core skills. MIT is developing such skill enhancement centers in its campus to give hands-on training to the students. MIT has developed more than 44 skill enhancement courses for the students and faculty. We are working on the model of the trainer first and have inculcated many skill trainings in the curriculum and along the curriculum for the students. MIT is motivating and supporting its students to work on projects right from second year and third year of their BTech program. This one-day conference will help the faculty members to get aware of latest innovations, technology, and research that will support MIT to further strengthen its skill centers. This platform will touch many more areas of research and development and will help us to think and understand the various opportunities in multiple areas. I also welcome all the faculty members and students present here on this occasion. I hope this conference will be a milestone for us. It will enlighten us with new ideas and knowledge. On behalf of MIT and MIT management, I once again welcome all of you at MIT Mirror. Thank you.
Thank you, sir.
Thank you very much, sir, for according a warm welcome to all the intellectuals and highlighting the achievements of Merit Institute of Engineering and Technology. And now I'm glad to invite Dr. Bhupender Singh Chauhan for giving us valuable insights on International Conference of Advanced Research and Innovation 2021. Sir, I'm sure that your address will help us a lot in understanding ideas on recent advances in various fields of science and technology. So, sir, please.
Thank you, madam. Thank you for giving me the opportunity. I wish to express my sincere gratitude to the researcher, academicians, scientists, engineers, technocrats from premier institute and universities gathered on this grand event to exchange ideas and innovation from all corners of India and abroad at ICARI 2021. This is the 8th international conference in a row and is touching new heights besides shaping the career of all aspirants from academia, research, industries, and related bodies. Motivated mind and positive Till date, our effort was recognized by various bodies like ISBN, DST, DRDO, etc., providing support as per time. We are thankful to our sponsor till date. However, 2021 was COVID, 2020, this year 2020 was COVID-19 year. Globally, ICARI regret for the suffering caused. Braving this major hurdle, new minds and aspirants have enthusiastically participated in the event. Life is the name of constant effort to fulfill dream for future. Every second is an investment for a big target and achievement. ICARI 2021 received more than 150 paper, but after a small this plagiarism and check, the strength reduced to 115. We try to incorporate all the papers for all aspirants because considering their careers, but the plagiarism check and language check and quality check, we cannot compromise. So the strength reduces to 115. This further after this reviewer comment, the paper will be filtered to get published by FME transaction, which is an ESCI journal, expanded SCI journal, and SCI this Journal of Engineering Research is an SCI e-journal with an impact factor of 0.387 as per the Journal Citation Report list of Scopus paper 2020. Both are listed in Cleverit Analytics. Therefore, ICARI 2021 is one step ahead this year. Thank you, and I wish all the authors, and I am thankful to every individuals present here, and all authors should get their prosperity in their life and career. So, with this word, I come to an end. Thank you, and I proceed in this share this screen to our anchor, and after that this session there will be a short break and then paper presentation will be there. Technical session, we share the schedule with the every individual to authors, and so I wish all the best, and if there is any query or any problem, you just mail me, WhatsApp me on my phone number, and just call me also. Any time you can communicate with me. Thank you.
Thank you, sir, for giving valuable inputs and offering us for assistance. Well, now I humbly request our respected Vice Chairman, Mr. Puneet Agarwal, who has been the driving force behind the whole event and has made all of us proud through his distinguished work in numerous capacities to address all the participants with your word of wisdom in order to formally start the event. So please.
Good morning to one and all, distinguished guests, researchers, faculty, and students. It gives me a great pleasure to be a part of this inaugural session of the 8th edition of International Conference of Advanced Mechanical Engineering Research and Innovation 2021. Last year, the edition was organized in physical mode in ITU, Delhi, and we had the luxury of physical and mutual interactions with each other. We hope that the same spirit will continue in this virtual edition also, and we should be able to share innovations and latest updates in the field of mechanical engineering which are happening across the world. There has been a global trend in the decline in the appreciation that was in store for mechanical engineering stream, which has been further aggravated by the ongoing epidemic. I feel that in such times, the importance of the roles that the students of mechanical engineering can play needs to be realized and it needs to be appreciated. The manufacturing sciences has to ensure that automation, but with certain flexibility, is there to cater to the unpredictability and fast changing market requirements that have incorporated the existing and future manufacturing systems. The transport sector, which includes your automobile also, is looking for a complete new orientation, which will involve lesser systems, which could be more complicated, but they will be more autonomous in nature. The logistics and supply chain is also seeking more automation. Thus, all the mechanical engineering systems We are looking at automation, which is going to be a key component, which is going to be a key component. The automation will require both hardware and software components. Thus, the students of mechanical engineering will have to ensure that they build up sufficient knowledge and skill sets, which will be a cross-domain expertise, which will also not only restrict themselves to hardware, but it would also include software components as well. Additionally, I feel that the consumers as such are seeking more feel-good products and services, which means that the consumers will not restrict themselves to functionality aspect of any product. They will go beyond the aesthetic components and they will explore the aesthetic component of the products, which will further require design interventions. The students of mechanical engineering need to incorporate the aesthetics and functional design components while they are developing new products and services. Thus, there is a need to appreciate the needs and wants of consumers before one goes on drawing board. The design and innovation has to be consumer led, it has to be consumer focused, and it has to be result oriented. I hope that this conference brings out some of the innovative concepts which adds value to the mankind. I thank all of you for being a part of this inaugural session and this conference. Wishing this conference a success. Thank you. Best of luck.
Thank you, sir.
Thank you very much, sir. Your thought-provoking address set a perfect platform for our speakers to deliver their presentations in various fields. We regret that due to some unavoidable circumstances, our chairman sir is not able to join this conference. But before we move on to the technical session, we would like to hear the experiences of our worthy guests. So for that, I request Dr. S.K. Varshney to grace the gathering with your thoughts and experiences. So please.
Thank you very much for the invitation. Very simple words, if I could say, that if you are not changing, if you are stand still, you are virtually dead. And research is the key to help you move. We have several examples where we have realized that if you are not adapting to the modern conditions, then you are gone. So example of HMT watches, example of Ambassador car, example of Nokia phones are with us, who could not get a space in the market, even though at one time they used to control the market. So change is the essence. We need to adapt ourselves to the modern realities, and that is what we have been doing. I come from Department of Science and Technology, where we are promoting research and technology, and not only basic sciences, but also the emerging area of sciences. I hope our fellow colleagues would discuss it in greater details. Areas like we have got a lot of emphasis on cyber physical system, which includes artificial intelligence, machine learning, big data, and application of these sciences to solve the societal issues at an affordable price. That is the key requirement. And we need to work that how our science is not only generating new knowledge, but is also good for our society, and how society would go forward with these new developments. It's high time that we realize the developments in different set of science. In a department, we are also working on ease of doing science. So we are working on a new science, technology, and innovation policy, which is right now open for public consultation. And I'll also request all of you to go to the website of the department and read this draft policy. And if you feel that there are some modification required, some changes required, it would be very useful to make your suggestions now. Already we have received about 100,000 suggestions, but since this is a phase of public consultation, your suggestion should be forthcoming, and it would be of great help to all of us. I'm very happy that MIT is organizing this international conference on several subjects, including mechanical engineering research and innovation. And I happened to participate in their last event at New Delhi. It was such an exciting experience to meet mix of senior researchers and young students. And I would urge to the young students to see what are the challenges, what are the issues that are bothering society within your immediate neighborhood. And if we could work out those solutions, that would be our bigger contribution to the science. And slowly, from local to regional to national and to international. That should be your approach. Second suggestion I would also like to make is take help of collaboration. Collaboration is very important because once you are coming from your own discipline, you have only one thought. But when you are talking to a researchers from a different discipline, for example, a physicist talking to a mathematician, a biologist talking to a chemist, so it always helps. And coagulation of ideas give help to generation of new understanding of the subject. So I would appreciate if collaboration could come, and this collaboration could be at your own institute level, where one faculty is helping the other faculty. It could be at the level of interinstitutional, so where you are collaborating with scientists, researchers of another institute, or it could be international. So collaboration is the key, and it helps us in cutting the research time, research cost, and we get benefited by the cross views of researchers coming from different sectors. So my request to you all would be to keep an eye on possible collaborators, work on in their directions, and move ahead. I wish all the best to this seminar, and I'm really excited, and I would like to learn from the experience, especially of the youngsters. How do they feel after interacting with number of senior colleagues from MIT and also from different institutions across the country? Thank you and all the best.
Now I request Professor R.T. Pandey from IIT Delhi to update us with your experiences. So please.
Thank you so much. I'm audible?
Yes, sir.
Yes.
You're audible.
Yeah, so I'll be talking through a presentation. So I'm sharing my screen. Uh, Screen is visible. May I request to know? Hello?
Yes, sir, you're audible.
Yes, I'm audible and the screen is visible.
Sir, your
Not yet, sir. Not yet.
Now?
Now visible, sir. Visible. Now.
Okay. So probably I have been given 10 to 15-minute time. So within that, I would like to conclude it. Whatever I am going to share, basically, this is a gist of a small, work we have done at IIT Delhi for developing the technology. So, very clear cut, I'll be talking in terms of technology and how things have been achieved. So, basically, we have used surface textures and biostructures. Surface textures, basically it is used to reduce the friction and wear, noise and vibration. And biostructures Just differently we are treating here, and we have developed structure, lightweight structures. So
programs and leadership in facilitating transportation leadership initiatives and activities inside of and
some background noise I am looking. Is it okay now? Can I speak? Hello, I'm audible?
Yes, sir.
Okay. So if you see machines, we know very well, basically assembly of various components are making the machines. And if you see the assembly of components when we are talking, so basically contacts are being formed. So these contacts may be concentrated contacts, means very small contact, and maybe large contact area, that is we call conformal contact, and small contact area non-conformal. So if you see ball bearings, gears, even in engine, piston ring and cylinder liner interface. So these interfaces, if you see, basically concentrated contact, means pressure will be very high. Pressure may be going to gigapascal order. And certain contacts, if you see, where a large contact area is needed, like bearings, if you see, or some other ball and socket joint, etc. So one can understand without contact, machine is not possible. So the issue is when contact is coming, then immediately problem is starting, because contact is not static, contact is dynamic. When dynamic contact is there, then friction, wear, and clearances and related noise, vibration issues automatically will come. So one thing is that we don't form contact. So if you are not forming contact, then obviously we cannot move ahead. So forming the contact, it is essential. And one point is that we have to reduce friction, wear, noise, and vibration coming out because of the interfaces. So today things are failing at the surfaces, if you see. Those days gone when things were failing in two parts, because technology is so mature, tools are available, so people can design that and that failure can be avoided. But if surface we are coming, let's bearing, ball and races where is happening, gears, teeth wherever it is there, where it is happening, friction is more. So there, if you see at the interfaces, technology is not mature. If particular operating condition, a contact is operating, this is perfectly fine. Its behavior will be something else, friction will be something else, wear will be something else, noise vibration will be something else. Same contact, if we operate at different operating condition, then obviously things will change. So the issue is that at the contact, things are not clear. And the way, continuum mechanics based concept, if you see, formulas are available, theories are there, models are there, such things are not there at the interfaces, at the contacts. So issue is still people are working to understand the temperament of the surfaces of the components and accordingly doing the manipulation for having a technical favor. So if you see here, surface textures, it is emerging, and when we're talking, the technological issues implying surface textures in 1-2 slides. So one point, if you are looking here in this slide, hope it is visible to you. So here microstructures, if you see, we see beehives, etc. So it is not beehives. Basically, whatever you are looking, it is from my house. So if you are looking this CFL bulb skew, so here attachment was there, and this is a titaiya, we call it here in local language. So then I thought, let us break it, and you'll be, happy to know, 400 gram when I applied load, and 2S type load cell I applied the load, and then contact it was broken. This contact at this glass tube and this. So which type of contact, which glue it was used, that is the question. Another thing, if you see the structures, so this is a very classical thing people use. These type of structures in order to achieve, high stiffness, lightweight, etc. But this concept we have used in one machine somewhere. So my interest is to show that one. And if you see here, let me keep my pointer placed at that place. So if you see here, so here also this is a basically wrapper it is there. So I mean, if you see the particular structure it is being given and ribs type of things are there and here. So it is a providing strength as well as air presence will be there. So whatever eatable items are there, that is not sticking to the surface, very neat and clean surface it is there. So since I mean quite long, maybe a couple of decades, people know all these things and they are using here and there and developing the technology. So here if you see this two concepts we have used here, a rotary vane pump, this is a vacuum pump, you know very well. In automobiles we use it. So if you see here, this is basically vane and I mean two chambers are being fired. One it is here, another chamber it is here. You can see here, one chamber it is here, here port is there, another port it is here. So one, I mean pressurized air will be there, another vacuum will be there. It's fine. So now question is, just I am running here, few slides very quickly I'll be running, then you will be understanding. So if you see here cover we have removed and a glass transparent cover we have kept here and we have screwed here. So right now whatever you are looking, it is appearing as if cover is not there, but cover it is there. If you see very quickly, so you are looking here and suddenly if you see the vane, so here spread of the lubricant is there. This is a vacuum chamber. And if you see, this is a vane and this is a polymeric material. And the tip of this polymer is interfacing this aluminum body. Because aluminum body means weight should be lesser. So if aluminum is present and any elastomeric material it is there, then friction will be very high. So issue is that at these two interfaces, friction will be very high. And if you see very carefully, then this slide vane, it is sliding. So let me go back and you're looking here very quickly, just I am turning the slides and you see here. And very carefully if you see where it is here, so little bending it is there. So it is getting bend here. So here if you see, this is a rotor and friction is present here between this and this surface as well as here and here. So the issue is that nowadays, you know, people, they are struggling to improve the efficiency and they are looking to kill the friction, some places at least. So, I mean, when friction is here, then it is not good idea. So we brought texture concept here at this. At the tip we kept here. And here, whatever when it was bending, you are looking, it is bending is there. So what we did here, if you see here, this type of concept we use. So here polymer layer is there, another layer is here. So using sheets only, this type of structure we created, whatever you are looking here. So now it was quite lightweight and this type of bending it was avoided. So lightweight and tip friction we reduce using texture. I'll be talking that how texture is, I mean, playing a role in reducing the friction. So this point, I mean, this technology we evolved basically. Now let us come to another point. If you see concentrated contact, when I mean we are dealing gears, we are dealing ball bearing, cam follower, etc. So we know, I mean, contact will be at point contact theoretically, but practically when load is being applied, elastic deformation will be there. So whatever line contact is there, that will be converted into maybe rectangular contact. Or if it is a ball on the surface, then point contact may be circular contact. So we know very well that when concentrated contact we are talking, so right now you are looking the segment. This segment is basically one ball. So how stresses will be varying? So you know stress won't be maximum at this point. So maximum shear stress, it will be maximum beneath the surface. So issue is that if this contact you talk, so if motion is happening at the contact, so what will happen? Friction will be there in tangential direction. If motion is here, then opposite to motion, friction will be there on the surface. So when friction is more, that time wherever dangerous point is there, it will sit to the surface. You are looking here, right now it is here, it is coming to the surface. So it is not coming at this position, it is coming at this position. So earlier it is here, now it is shifting up. So the issue is friction is very dangerous. Means wherever wound is there, suppose we are saying this is a, I mean, very critical point. So this critical point, it is coming to the surface and it will be having exposure, and which is a very dangerous. if any wound is there and that wound it is open, then obviously it is going to be detrimental. So you are looking here, same concept is being explained, and when friction is present, so these are the isochromatics, basically maximum shear stress at the contact, how it will be distributed. We are looking, it is shifting to the surface. Now it is getting disturbed. So the issue is that when we are reducing the friction, then obviously tangential component will be less, and combined loading, when we are talking at the contact, then combined loading basically it will be mainly comprising of compressive load, not tangential load. So the concern is, we know very well all these concepts. Here if you are looking, I mean grease it is being used, and our colleagues must be knowing that when we are going and purchasing any bearing in the market, then lubricant won't be there inside unless it is a seal or sealed bearing. So if it is open bearing, then only petroleum gel will be there, and that gel it is used so that corrosion should not be there. So once bearing it is purchased, then there is a need that particular grease, appropriate grease should be selected, and it should be used for lubrication purpose. So you are looking here, two greases have been used. So this grease you are looking yellow color. This is a very low energy number, means fluidity is more. And if you see here, NLGI number is very high. So its fluidity, if you are looking, it is poor, means it is having relatively more strength, yielding strength, grease. So now question is, when one ball it is being kept and it is rotated. So you are looking here after rotating couple of times. So we see that grease presence on the contact, it is not there. Means grease is getting pushed aside. And similarly, if you see here, low energy grease when we are using, also it is getting pushed aside. So enlarged view of this and this you are looking. So if you see on the track, grease is not there, grease is getting pushed aside. So once ball it is moving a few turn, it is doing, we are looking this situation. So in reality, bearing what it will be doing, you know very well that grease won't be there. So only lubricity or little bit traces of grease or oil may be there at the track. So one way we can say that film formation at the contact is not there. So ball bearings are concentrated contact machine elements. They are prone to vibration because damping action is not there if fluid is not present. Other damping may be there, frictional damping, other form. But right now we are talking damping because when unwanted vibration means mechanical vibration. So mechanical vibration, basically unwanted energy, it is there here. And this energy should be converted to heat energy through viscous heat dissipation. So presence of lubricant at the contact is needed. So here one technology we have developed, if you see how to retain the grease at the contact. So basically you are looking at this surface texture. So basically snake. If you see the snake bottom side of this, then probably you might have seen this type of texture. So this type of texture we have created here. So when this texture is created, so retainability of grease it will be there at this texture, and then bleeding of oil will be there, and this oil it will be coming at this contact. So whatever right now you are, this groove, it is appearing, but it is a very tiny groove. You can understand, 10 micrometer. So 10 micrometer, if physical sense you want to understand what is 10 micrometer, you can take your one hair, एक बाल लीजिए अपना, and the diameter of that hair may be 40 to 50 micrometer. Maybe, if it is thick hair, then it may be 80 micrometer. So you can understand 10 micrometers. So if you compare, means by naked eye, it is a little difficult to understand where scratches are present or not. So this technology we used, and really, fatigue life, vibration and noise of the bearing, drastically we have reduced in comparison to conventional bearings. And similarly, we have used in power transmission systems, gear. So longer life, longer reliability, high reliability life. So here also we did texturing. So if you see, because participants must be knowing, even in their machine design courses, it must have been taught that the surface should be mirror finished. The reason is fatigue life will be more, because even textbooks, if you see BTech, MTech level, you'll be finding it is very clear cut written that mirror surface will be there, then fatigue life will be very high. The reason is these scratches will work as nucleation crack, and through passage of time, propagation of the crack will be there. Then catastrophic failure suddenly without any alarm it will happen. What this is the mechanism, it is reported in the book and our teachers teach, and this is the mechanism of fatigue failure. So here deliberately when textures are created on the surface, then where is a fatigue? Why things are not failing? What happened? Our understanding earlier about 40, 30 years back, what we developed, that was incomplete understanding, because everywhere we said that mirror finish surface should be there, and deliberately textures are being created and different type of textures are being created and better results are being achieved. So certainly something has been missed, and that probably if time will permit, I will discuss with you. So here if you see film thickness also we have measured between the gear tip. So here resistance concept we have used, and if you see both the gears are revolving, so here miniature bearings are being used at this end, at this end. So the issue is when we used texture, then fatigue life enhanced, friction reduced drastically, temperature rise reduced drastically, and overall reliability increased. And we know very well that gear lubrication is very tricky lubrication. Effective lubrication, it won't be there at the concentrated content. So what is the physics behind this? What is the mechanism? So we should understand that when textures are being created, then one concept is that these tiny textures, innumerable textures, maybe micron size or sub-micron size or nanoscale size, so they work as a lubricant reservoirs. It is fine. So the issue is that when there is a gap, desirable gap it is there, then if you see here quantity of lubricant at this section is more, but when you are coming at this section quantity of lubricant will be lesser. This is not pipe flow problem. Basically one surface, if you are looking, this is a pad, you can say one plate it is there. So this plate it is stationary, and this plate, this is a runner, it is a moving. So it's not pipe flow problem that wherever pressure energy will be there, then kinetic energy will be less and vice versa. So here we understand what surface is moving. So this surface will carry the lubricant because lubricant will be adhering to this surface and it will be dragged inside the contact. So here quantity of lubricant at this section will be high, at this section will be lesser. Why? Because velocity is not changing. The surface, it is the same. So velocity everywhere will be u. And here at the surface, if slip is not there, everywhere velocity will be 0 because this is the stationary surface. So whose velocity? Lubricant, fluid velocity. The issue is that more lubricant is here and less lubricant is here. Then what will happen? Per unit time, more lubricant in a space entering and less lubricant per unit time is coming out. Then congestion will be there and pressure buildup will be there in the film. And this pressure buildup basically one root pressure profile. So this phenomena which will be happening at micron or nano level. So when pressure roofs are there, so these pressure roofs will be pushing this loaded surface. So there will be a gap. So dry contact or solid contact has been replaced by fluid contact. And we know very well dry friction is many times more than fluid friction. So this is the way how energy efficient contact it will be coming. And if suppose somehow lubricant scarcity it is there or load is too much, film formation is poor, then this type of situation may be there. SPLT to SPLT contact will be there. So when motion is happening, so these micro pockets, sub micro pockets or nano pockets where lubricant is there, so this lubricant will getting smeared at the interface. So basically lubricity will be improved and it will be survived longer time even if a lubrication line has failed or some negligence is there for some time only. And it works as trapper of debris and contaminants also. So these basically three core things are there, which is improving the things. Now one may say that when you are creating texture, micro pits, etc., it may be detrimental. No, it is not detrimental. The reason is because fluid under pressure is there. If suppose we are cutting dimples, etc., but that dimple is filled with pressurized fluid, and the value of pressure is very high, gigapascal order, or we can say strength of the material order itself, whatever yield strength is there. Then obviously, fluid, here crack won't be propagating. Even pulsation nature it is there, then crack won't be propagating because dampening action is happening. So very quickly I will be finishing because time I won't be taking, others are there. So here one technology we developed, and basically if you see drastic friction reduction has taken, and ball bearings if you see, temperature, this is a thermography image you are looking, and if you see lubricant retainability is outside. So in real running situation, we observed that where grease is present. So if you see the race, lubricant is not there. Similarly, in engines, we developed technology. So if you're looking here, this is a piston, and piston rings are there. So here we did certain surface texturing and design of the piston ring. Here also we have saved fuel, and emission has been reduced because per unit time lesser quantity of lubricant is getting burned. So if you see this primary motion, it is consuming fuel, and this secondary motion, it is consuming lubricant. So there is a need to strike a balance. Now I'll be very quickly finishing. So here we designed one rig, and we have measured the film thickness, and this friction also we have measured it. So the issue is when only one piston ring it is textured, then if you see about 20% friction reduction it is happening. So these textured piston ring we used inside an engine. We conducted the experiment, and then about 4% fuel saving we got. Though longer duration experiments were not conducted, the reason is resources were not there. So I would like to finish at this point. Because time limitation is there, accordingly things have been kept on the slide. So in presence of microstructures, surface textures, drastically we have improved the dynamics, noise and vibration reduced, and power saving it has happened. And particularly when lightly loaded condition is there, surface texture, it is a boon. So here I would like to conclude this talk, and certain biological structures we are exploring here to develop lightweight technology for space. Just I am giving ideas so that our young participant students they might be knowing all these things where research is going on. So thank you very much for listening. Thanks a lot. I would like to request Professor Bhupendra, you remove my slide there. Probably it is hanged from my side.
Okay.
Thank you very much, sir. And now, may we have the pleasure to hear from our next keynote speaker, Professor P. Chang Lim from Busan National University of South Korea.
Good morning. May I share my slide now?
Yes, sir. Yes, sir.
It's okay?
Okay.
May I? Right, good afternoon. Oh, good morning, everyone. Because it's here, it's afternoon now. So, well, honorable professors and scholars from the various universities, distinguished researchers and guests, and ladies and gentlemen, well, I'd like to say good morning, right? So my name is, as you can see on the slide, Hee Chang Lim from School of Mechanical Engineering, Busan National University, Busan, South Korea. Okay, that's actually Republic of Korea, not North Korea. Okay, well, I didn't have any introductory remarks actually in the beginning, so I just want to have a talk, very short actually. So even though the COVID-19 pandemic continues to have a huge impact on face-to-face scientific meetings throughout the world, well, I'd like to let me begin by expressing my sincere congratulations on this ICARI 2021 conference. And I'd like to give more gratitude to all the organizing members for organizing this conference after last year's successful hosting. Yeah. Well, unfortunately, this year, no, it's pity not to join the conference in Delhi, but still it's okay online conference. Right. Well, anyhow, it was difficult to choose my topic at these occasions because my allocated time was limited and the rest of time should be shared with other professors and scholars who possess great experience and better potentialities. So therefore, I made my mind to deliver some brief introductions of my background and research interest in these occasions, which is more effective to um, share my experience to you better. Right, let's firstly look at the front page. As you see, the title is now simply how is the field, F-E-L. Here the field represents a nickname of our laboratory. It is called Fluid Engineering and Exploration Laboratory, which very funny, but I think is better to remember. Okay, right. Well, as you can see my face images and details, you can find my contact detail, which is more effective to show my experience. So in this slide, I would like to sharing my research interest. So as you can see, firstly, modeling wind flow over fluff bodies and turbulence boundary layer flow with AI and deep learnings, which is very popular topics in the world actually. So we actually try to simulate the turbulent boundary layer and then we reproduced the turbulent boundary layer actually in the artificial domain. I'm not going to tell you this one more detail, but this is mostly I'd like to introduce some part of my research area, and then you will see how it works and see the brief, contents about my background. So the other and the other areas would be electro ratings and high pressure dynamics and CFD and visualization and image processing techniques. Okay, right. The first topic I would like to introduce is the modeling wind flow over bodies. And this topic basically dates back to around 10 to 15 years and still ongoing work in the laboratory. This work investigates actually experimentally and numerically on the flow around the simple three-dimensional obstacle or buildings, whatever, in a simulated atmospheric boundary layer. So as you can see in the figure, we try simulate this kind of flow in numerical domain. And as you can see here in wind tunnel or field, actually this actually the real field. So what you can measure here, like the velocity and pressure or some other temperatures like that. So in this case, or what we use here is something, the measurement tools. So something like PIB, LDB, and hot wire anemometry. So PIB actually something like particle image velocimetry. And a point-wise measurement such as LDB, which is laser Doppler anemometers, and HWA, which means hot wire anemometries, will be very useful tools to measure velocity. Okay, and the unsteady pressure sensors has been used to understand the link between these motions, these flow motions, and the unsteady surface pressure field. And what I'd like to do, what I would like to understand here, this is the importance of the scaling effect between the laboratory and full scale situations. So as you can see in the figure, Reynolds number covers 1 times 10 to the 4 to 1 times 10 to the 7, which is the case of field measurement. So the figure in the left, you see the velocity on the top of the bodies here, 1 to 2, was successfully well agreed together, and the surface pressures uh, the, along the center line of this body was also agreed well agreeing well between the numerical simulations and the measurement. That was really interesting topics last to 10 and 15 years. Right, see here. Okay, so as I mentioned earlier slide, is the PIB measurement was one of my measurement tools and captured the two-dimensional velocity field by using optical lens with laser system. However, without the proper software to predict the wind speed in the images, it would not be useful to use only hardware. Okay, so there has been a development of PIB software in our laboratory. So see, what do you see here in the figure? What actually do you see in the images here? There's a lot of particles and photo particles in the images. Actually, these images include two consecutive artificial particle images, which simulate the shear flow on the right figure. Okay, well, I'm not sure why it's not moving here. Actually, this one is the movie clips. Actually, particle moves in these images, and that if you analyze these particles, you can get this shear flow. Okay, so right plot shows the velocity profile. So this technique can also be applied to a variety of applications, such as the wake flow behind the square cylinder or flow over a cube as shown in the figure below. Okay, right. The next topic I have been interested in is the renewable energies. In particular, wind, as you can see here, ocean energies, solar, and biomass. So in these slides, as you can see, the offshore wind turbine would be one of the targets we have tried to develop in the laboratory. So the measurement could also be important, but in this slide, only some of numerical simulations are presented. Okay. The grid and mesh of wind blades could be made, and moving grid simulates the rotational effect of blades. So in order to visualize the wake flow behind the blades, as you can see the figure on the right, the isosurface vortices are presented on, you can see on the right figure. Okay. Right. The next one is, depending on the way how to use CFD, the application would be very huge. Okay. In this slide, the flow inside the cavity could be visualized depending on the shape and appearance. So actually, you can apply these cavity floor, something like rectangular cavities, or something like arbitrary cavities, and then the cavity, there is obstacles in the cavities. That's a variety of application to use these cavity simulations. Okay, well, due to the limitation of times, I just try to give you some brief introductions. So if you are interested in the radiated noise predictions by FSI, FSI means fluid structure interactions, then you can use, in this case, the multiple softwares such as SysNoise, and then Fluent, Star City, Ardina, and the Nastrans, or maybe ICM CFD, whatever. So they are mostly relevant to predict the floor, vibrations, and noise, etc. Okay, so there will be one example of them on the figure bottom. Okay, you think about the muffler in your car. The mufflers are generating noise, and you will find a way how to propagate the noise, how to or where from and to, based on your acknowledgement. Okay, you can use this kind of topics. So the flow shake these plates, and the plate generate the propagates flow to the external space. Okay, right. The physics of micro and the nanoscale floor would also be interesting to explore in this area. I started this area with the flow inside the droplet, shown in the upper left figure here. I started with this figure like that. And after that, I measured the variety of the shape effect of droplet, like depending on the concentrations and temperature and vibrations, you will think how the flow is like. Okay, you can also think about the figure on the right. If you shake the bottom plate in certain frequency, you can observe the variety of the structure in droplet. Okay, actually we call this one the jumping droplet, and depending on how you shake the droplet, these varies variety of shapes. Okay, right. So I'm sorry that I have to straightly go to my last slide with thanks to my colleagues in the laboratory. Since our laboratory consists of the variety of foreign students and they do study well. So I would like to thanks for all of their effort in this case. So I put their name on this slide. So once again, I'm really sincere honored to be here in ICARI conference, as I strongly hope and know that you will find the conference extremely stimulating and enjoyable. Thank you. I'm done. Thank you. I'm not sure you hear well.
Am I audible? Will you please acknowledge me if all of you can hear me?
Hello, I cannot hear properly.
Well, now I would like to request Mr. Pradeep Chaturvedi, our guest of honor for the day, from Quality Council of India, to update us with your precious inputs. So can you hear me?
I can hear you clearly.
Okay, sir. Please go on. Thank you, sir.
Yeah. Good morning. I'm grateful to Shri Bhupen Chauhan of MIET for inviting me for this important international conference of advanced mechanical engineering research and innovation. It's a wonderful opportunity for the institution to organize a discussion on this topic. I know this is not the first one, but since it is coming out immediately after the impact of the COVID-19, and most of the industries, the businesses that have reopened after COVID-19 had either the digitalization effect, but most of the industries had lots of mechanical engineering inputs, and that has been a very major thing, the innovations that have gone into the mechanical engineering field during the COVID period, during last 8 to 10 months, and all such industries that have reopened, they had something or the other to do with the mechanical engineering inputs. And therefore, to organize an international conference at this stage is a really very appropriate thing. And I just heard the two scholarly presentations which went deeper into the science of engineering of mechanical parts. I'll rather like to cover on the part of how the industries are looking at it, how they are opening up, and how the mechanical engineering inputs mainly the innovations will play an important role. You know, the Institution of Engineers has just completed its centenary, its 100 years. And on that occasion, we published also the centenary book on engineering for the future. I had the privilege to edit, and there we have got 32 of the best experts to write on these aspects. And virtually the focus was that we are
Unmute
in a
करो
new
ना,
normal.
mute करा
We
हुआ
are, we are changing away
है।
from how the world had moved in the past and how the world will move in the future. And in all this, the industry will play an important role. The academics have to really support, but industry has to put in its own money and to see the opportunities where the opportunities lie. Uh, Fortunately, many of the multinational corporations and the larger industries in India have seen that COVID as an opportunity, and they have reopened after the COVID impact or even during the COVID period. Uh, uh, the first one off the hook was the automobile sector. The way they have, most of these companies, they say that what they had planned to digitalize or to reform and bring in automation in over next 3 to 4 years, they had hastened up and they could bring around in about 3 to 4 years. And man-machine interface, which is most important in this, was also really brought to the surface. The academics have played a very important role, which is really not seen. But with the industry and the governments are a national effort of Atmanirbhar Bharat, which at one time was thought as an anti-globalization process. But now, if you look at any of the European countries, even Americas or the England, they're all going into some version of the Atmanirbharta. They're realizing that they have gone away from the engineering industry, and therefore they don't have their manufacturing facilities, and the kind of problems that they're facing are really immense. They are reopening up. Now, here are one of the important aspects of Atmanirbhar Bharat has been the role of the MSMEs that they have played. And it has been observed in a report which has come out in November 2020. It shows that a large number of startups uh, owned by young engineers who have just been out of the engineering colleges, maybe within last 2 3 years, they may be BTech, MTechs, or the PhDs. They have developed the technologies for the occasion in a much faster manner. But only thing is that there's a big shift in the whole approach. Earlier, MSMEs were all being looked at as part of as ancillaries, playing a second fiddle to the large companies. But this new intellectual lot has really been a great asset, and they have brought in lots of innovations which were not thought of by anyone. But these innovations are at the cutting edge of technologies which no one thought that just fresh pass outs or those with 3 4 years experience could be working. They have attained these kind of innovations which are really helping a lot. Now we should also realize that we are entered into a new normal, into a new era. The way, four major things, four major trends that have now come in. It is a combination of heightened connectivity, and this connectivity leads to the people taking actions at a faster pace, and one can't be just logged behind a keyboard and press. The second is the lower transaction costs. All the earlier industries, they had the loaded transaction costs, but those transaction costs have come down, changing the whole metrics of the economics of the industry. And therefore, the future of engineering approach has also to take this into consideration when we do our research. The unprecedented automation, uh, uh, not only in India, all over the world, the automation has moved at such a fast pace that what we are looking at to achieve at a much later date, we are able to do it in 8 to 10 months. And then there are shifting demographics. So these are the four major changes that have also brought around the whole engineering fraternity to think as to where will the future of the engineering be. Now there are future. Ultimately, we have to convert the engineering and the technological outputs into their GDP values. Now it has been realized that the future-ready companies share three basic characteristics, and these are very much fulfilled by many of the startups and the MSMEs that coming in. They know who they are and what they stand for. I mean, everyone run of the mill will may or may not survive the market thing. You have to be very specific and move very at a very fast pace. Second, to operate with a fixation on speed and simplicity. You see, it says you have to work at a fast speed, but at the same time, your processes and your presentations, communication skills have to be simple. They grow by scaling up their ability to learn. And now this is a very important thing. They grow by scaling up their ability to learn, innovate, and see good ideas regardless of their region. And that is where your today's international seminar has a very important thing for the future companies as to how they'll get and move at a faster pace. See, the whole engineering, the whole mechanical engineering field has to undergo a major change. If we focus on the education system for artificial intelligence and automation, then our processes have also got to be changed. We can't So the whole process has to be linked to how academics link with the industry is an important thing. Now the future ready organizations accomplish these in three different ways. They get clear on their purpose. That's the first part. They know how they create value and why they are unique. And third, they create strong and distinct cultures that help attract and retain the best people. Now, I've just seen. I think this is the fourth edition of this, this effort of innovation. But really speaking, what all MIT has done has been very much keeping in time, and their approach presently is of a very important at a very important juncture. Since MSMEs and the startups have to play important role on innovation and all. I mean, it is the institutions like MIT which have to play as an interface between large academics, government, and the startups. And here is an opportunity. I'll wish, since MIT is placed at Meerut, which is very close to many of the major towns and cities where you have the industrialization taking at a fast pace. I'll wish the outcome of this seminar is made available to all in the government and all the professional institutions. And you also get in touch with the nearby industries, organizations. Your institute, the MIT, could be one of the leading lights in this region. I wish your seminar all success, and thank you very much once again for inviting me for this. Thank you.
Thank you very much, sir, for your patience and for recognizing our efforts. On a positive note, it was really a pleasure to hear from you.
Thank you.
Sir, thank you once again. Yeah. And now I request Dr. M.K. Pataria from the Department of Science and Technology, who is our guest of honor, to say a few words. Welcome,
Hello.
sir. Yeah.
And I'm very happy to see my old friend and my senior, Shri Pradeep Chaturvedi ji, who belongs to Quality Council of India. And he has been
Same with you, Pataria ji.
our
I'm
guide.
also very happy to see you.
Yeah, thank you. Thank you.
Namaskar.
Dr. Sanjay Mishra from DST and Director Maitri and all dear colleagues, Dr. Bhupender, dear participants, and all friends. I'm really delighted to be part of this international seminar that I have been attending for last couple of years. And I would like to put forward a couple of my yesterday thoughts on this occasion, especially for science communication, and that is my area of interest for a couple of decades. Whatever research is happening in India, and that is very important, But when it comes to connecting that research to the masses, especially we find it very difficult because this has been the discussion for a long time that our scientists are, although there are exceptions, but they are not the good communicators, they are bad communicators. So how to convert scientists as communicators, that has been a challenge. At the same time, we have yet another community that is called journalists. And journalists also, because they are coming from the background of humanities, they don't come from the science background, so they also find it difficult when it comes to communicating science stories to the media. So for that reason, we require a kind of fraternity, especially those who are interested in communication, the scientists, those who are interested in communication, at the same time, the journalists, those who are interested in science, they can come together. So we are trying to put forward this kind of fraternity who are really willing to take up science communication as a career, as an area of research, as an area of profession. And for that purpose, we have started number of courses leading to MSc and PhD in science and technology communication in different universities. And more recently in the National Institute of Science Communication and Information Resources, that has now become NISPAR after incorporating NISTARTS into it. So that is really picking up very well. And something like 50 scholars, now they are pursuing their research in science communication. So science communication research is yet another area of activities and expertise, especially those scientists who are really willing to pursue science communication. They can join all these activities. And a number of now new avenues are coming up for science communication, ranging from research to long-term and short-term trainings, not only in science communication by and large, but also different segments of science communication, be it print media, electronic media, digital media, and now we are what we call is social media that is coming up in a big way. So a number of things are happening. Recently, one of our sister organizations, that is Vigyan Prasar, has started an OTT channel, over the top TV channel or internet, under the title India Science. It is available free of cost with the help of an app that can be downloaded from Play Store or other such services on your mobile, on your laptop, on any electronic gadget. And you can watch that channel 24/7. So these are some of the milestones which are really very encouraging, that have been thought of a couple of decades back, which are now being realized. Similarly, a kind of new agency of science and technology is also coming forward. And the idea is whatever research is happening all around the country, all around the globe, especially to begin with, has to be made available to the media people, so that they can really put it on their respective channels of communication, be it electronic media or digital media or maybe print media. So this is the way how we can enhance science coverage in mass media. As a matter of fact, couple of years back, we have conducted a survey, and as per the results of that survey, it came to the fore that the coverage of science was like 3.4%, and that we intend to increase to the tune of something like 10%. Media of the country. Incidentally, the television has, especially Doordarshan, has a coverage of something like 97% geography. Radio has something like 99.999% geographical coverage. A huge publisher of various daily newspapers, and I am very happy to share yet another achievement, yet another communication. We have been able to start a fortnightly newspaper titled Vaigyanik Dristikon, that is coming out every fortnight, dedicated for science communication. And now we are putting in our efforts to start a daily newspaper on science and technology. So these are some of the features which are really very, very important. And at this moment, I would like to invite all the scientists, all the scholars, all the participants to not only contribute to all these activities through all these media, print media, electronic media for science communication, but also join hands together for really have a synergy in research and development as well as its communication. And as far as this communication for children are concerned, we have started National Children's Science Congress, and through that we are encouraging the students and children from class 6 to class 12 to develop a kind of scientific bent of mind that we call the scientific temper. The idea is, generally you must have seen various science exhibitions. So different, all these activities for children have different objectives. Incidentally, this Children's Science Congress has a kind of different perspective. It has nothing to do for developing model, or it is something like developing a kind of project report, so that the students from the very beginning, they come to the fold of research and they realize, they understand the mathematics, collect the information, how to analyze the information, how to go for experimentation, and finally reaching to the conclusions. So this is the way we are trying to inculcate the spirit of method of science, the spirit of scientific temper from the very beginning. So these are some of the aspects I would like to share with all of you. And one last point I would like to make: outcomes. It is not only for writing papers or getting patents, it is also connecting that research to the industry, so that the fruits of the scientific research and technology can really reach to the nooks and corners of the country. But as a matter of fact, it has been it is being told that whatever research areas, they are the affair between two people, two persons. One the scholar, other is his or her guide. So these two persons decide what would be the fate of the research. Whereas the requirement is to this research design has to be critically examined, has to be critically, I think, evaluated, so that we are able to develop a right kind of research design to solve the country's problems. Because as a matter of fact, number of things we are taking threats from whatever thread we are taking from outside what is happening, and we are really enhancing these threats in our research. Whereas what is required, the Indian situations, like we have the problem of potable drinking water, we have the problem of energy solutions, we have various health problems, we have various cultural problems. So how about picking up a subject of your research, of your topic, that can really address that problem, at least make some dent towards addressing these problems? So this is how I would like to suggest that our research designs has to be very robust, has to be more closer to our own solutions. So this is how every year number of PhDs are coming, number of researches are coming. So these researches would be able to bring in these solutions. I think that would be very, very important. And yet another point I would like to make: recently we have been able to organize a program on. We had a project called Vaccine Project. It is something about vulnerability assessment of climate change and global warming. Global warming. So we have identified three very vulnerable areas. One, the Himalayan areas, the other one is Sundarban areas, and the third one is Lakshadweep and Andaman Nicobar Island areas, because there you can visibly watch the changing taking place at a very minute level, which are really measurable. So we organized a kind of demonstration of the technologies which are really important for the climate change perspective. So as a matter of fact, a technology that was developed by a laboratory of CSIR, that is CSM CRI Bhavnagar, Central Salt and Marine Chemicals Research Institute. Not now, something like 20 years before, 2 decades before. It is something about desalination of saline water and turning it into potable drinking water with the help of solar power. So this is a very simple technique. So the local administration of Lakshadweep was very much interested for installation of these gadgets in various islands. But when we inquired about its commercial viability, we found that it was invented something 20 years back, but it is very exporting and promoting new technologies. As a matter of fact, in a recent meeting, I came to know that India is exporting something like India is importing something like 96% precision technology from outside, whereas we are the third largest country of producing research papers. We are the third who possess the scientifically and technologically trained manpower in the world. So look at the scenario of why it is not happening. So I think this is the time, this is the high time to really encourage our youngsters, to encourage our researchers to think on these lines, so that sooner the better we should be able to becoming from 96% precision technology importing country to 96% precision technology exporting country. And that would be a great change. So with these words, I would like to thank the organizers for giving me this opportunity, and I am very happy to share my thoughts. Thank you very much. Namaste.
So we are equally happy, and it's really an appreciated step that you have taken. You truly said that journalists really find it difficult to talk in terms of science and technology. So I would also like to opt for such a course, as I'm also from that background. And thank you very much for all the valuable inputs that you have given. Now I would like to request our Honorable Director, sir, for the announcement of awards.
Uh, Good morning, everybody. I want to welcome Dr. Professor R.C. Singh from Department of Mechanical Engineering, DTU. We want to announce two outstanding contribution recognition awards to Professor Dr. Nand Kumar, Department of Applied Science, DTU, and Professor R.C. Singh, Department of Mechanical Engineering, for their outstanding contribution for the International Journal of Advanced Research and Innovation in past year they have done. I congratulate both of them, and thanks for their contribution for this for the journal. Thank you.
Thank you very much, sir, for announcing the award. And on this momentous occasion, it is a proud privilege and fortune to welcome Dr. Sanjay Mishra, who is our chief guest for the day. Sir, I would like to, we would like to hear a few words from you. Am I audible?
Okay. Yeah, good morning, everyone. I think I was muted. So good morning, everyone. First of all, I would like to thanks to the organizers, Professor Chauhan and MIT team for organizing this, international conference on advanced mechanical engineering research and innovation, and giving me this opportunity. And secondly, I'm very happy to see the familiar faces, from my department and from industry, from Quality Council of India, from IIT Delhi. So it's really exciting to listen and to have interaction with the gathering. Now, I think already several things have been taken care of, several issues have been taken care of. I would like to point out a few points or few issues for the benefit of the audience, which is consisting of the students, postdocs, and some young faculty members. So that is my primary audience. So my discussion, I will say, or my talk is more geared a message to the young researchers. So first of all, as you have seen this mechanical engineering, I myself is mechanical engineering, by the way. So I can see the mechanical engineering, if you look at the historical perspective, this has changed over a period of time. In 50s and 16, we used to, I remember the steam tables, like from a steam engine, that was I will say, the primary prime mover of the industrial revolution, where the mechanical engineering you can start. Then you have the automobiles, then you have the several, power sectors, power generation, automobile, and several areas of mechanical engineering, what we call the conventional mechanical, which we were taught in the 80s, if you go back. Then slowly, if you look the mechanical engineering domain as such, in last 2 decades, Then you find that now the modern, the outcome, everyone knows the 3D printing. Now we used to work the classical model of the production technologies, where you have the lathe machine, drilling machine, you have gears, and you have got all sort of things. Now 3D printing, which is now a buzz kind of a manufacturing technology, which is coming so much into the modern usage in different walks, whether it is the robotics, whether it is the manufacturing, all sort of thing. Then another branch which has come out is, you all know about the mechatronics, which is mechanical engineering coupled with electronics. Because if you look the simple car, like I remember the days of ambassador car, like the Fiat car. Every part, even the dial used to be pure mechanical, springs and rollers and everything was mechanical. Now you find any modern car, you'll find at least hundreds of gadgets are purely control system based, electronic system based, which are sensor based. You have circuits, you have got the integrated, circuits, and those technologies are coupled with the automobile. So when you earlier, I used to think as a car as a mechanical engineer, that's my domain, or a pump. Now you see the pump is also coming in a hybrid model. So the point what I see and the message which I wish to give to the my students and my researchers is that in last 2 decades, the technology is fusing. The boundaries between the various branches of engineering is being weakened, is being broken. So, as my friend Sanjeev Vaishnav has pointed out about multidisciplinarity, so it's true for mechanical engineering. The today's avatar of mechanical engineering is very, very different than, like 5 decades or 4 decades back of mechanical engineering. So I'm very happy that the organizers of this conference have taken care to invite the papers from different walks of the new areas of the mechanical engineering. For example, the smart materials. Now, for mechanical engineering, I personally have moved into biomedical engineering, now, which is again is a marriage between medicine and technology. All branches of medicine, which is cardiology. Then you have then a mechanical engineering person can interact and make the cardiac, stents and valves. Then you have orthopedics. It goes with the mechanical engineering. And you can always work for the artificial knee joints, artificial hip joints, bone plates, bone rods. So and even for the various branches of medicine. So the point I'm trying to make here is that probably the time has come when no single discipline can move ahead in terms of the research, in terms of the product and processes. So the marriage between the different disciplines is a must. And that is the point which has already been highlighted earlier also, that the new researchers have to have a collaborative project in order to make something meaningful, something useful. Because a lot has been already done in a classical method as a single discipline research one. So this is the first point. Now the second point is about the one issue which my friend Manoj Ji Pateria ji has also highlighted briefly, and but which is close to my heart and which I wish to highlight to the everyone here, my senior friends and my young friend as well. Now, as you all know that India has done very well in the research publication. I will call it knowledge creation. Okay. So whether you do an experiment or you have a theoretical model, computer model experiment, you create some knowledge. And that knowledge, if it's a novel knowledge, new knowledge, it gets the place in a research publication, what we call a index journals, and that is what. Now, India has done very well on that part. Now, the second part, which is not so good story, that is the conversion of these knowledge into the products. The via media is called the patenting. The next step is going that if you produce thousands of paper, maybe only five of those knowledge can be created into patent. And out of the hundreds of patents, maybe thousands of patents, only one will come into the product level. And out of the hundreds of products which come into market, maybe one or two will penetrate the market, will sustain for into the market. So this is the kind of the filtering effect which occurs. Now, most of us, I mean, I see even in my department also, DST, when get the projects, it is always easy to get the research papers. It is extremely difficult to get the patents. Again, extremely difficult to make those patents working into the modern into the market one, which are really useful to society. So the point I wish to make is that, like I think in number of patents, if you see the last year, I think it's in my head somewhere, I think 12,000 and few thousand. Whereas if you look at the other countries, even the Korea, even the China, it's not 2 times, 3 times, 5 times, it's more than 100 times. So the scale where we are lagging in this patenting and conversion of the knowledge into this area, need to be addressed by everyone, not only by the young researcher also, but also by the policymaker and also by the directors and by the professors and everyone, including the industry collaboration, that where is the market space, where is the scope for making the products. So that is another point. And here I would like to make one request, because a lot of us are from academic background. At least to the best of my knowledge, is still sometimes our policies of the PhD work, sometimes they restrict to go into the patent line versus the publication line. Like I remember in certain universities abroad, I used to be there even 20 years back, like in Oxford University, when you are submitting, when you are registering for your PhD program as a student and supervisor, can fill up a simple form that, okay, I'm trying to create an IP and I'm not going into the usual conventional path of PhD where you are expected to have 2 or 3 publications, because if you publish, then you cannot do patent. And even those PhD vivas were done in a closed door. Their theses were not put into the library. Everything was done very secretly to safeguard the IP. Now, I'm not sure whether we have got such systems right now in the universities or other places where right from the beginning of your project in PhD, you can choose a path. Your aim is to have a patenting one, number one. So if I will request the policymakers at the academic administrator to look over, because then only you can safeguard. The moment you publish your thesis, it is a library, it is open defense. You can't patent. So this is just one quick, very small point. Similarly, there are many other layers which need to be addressed, because the whole system need to be re-looked and redesigned to safeguard the IP one. Then the other point which I wish to make is I was talking to the organizers also since morning, and I'm very happy that I think earlier also my speakers have pointed out that we all of us have passed through a very traumatic phase of the pandemic in last 6 months to the 9 months. And I'm very happy for the organizers of the this MIET who have thought to have this conference, or the online conference, where the opportunities are coming for the students and for young researchers to make their papers. So it is a positive thing. So I must congratulate to the organizers for this organizing in such a time one. The other point, as a DST person, I would like to again make it very clear to my young faculty members and students that I've been in DST from last 8 years, and I can't remember one committee meeting where we select the projects where one project which is of good quality has been rejected for lack of financial support. Always, invariably, I found that we have the slots, but we are not getting the quality research projects with a good solid homework, where the literature review is perfect, where there is a clear-cut definition of the question and the methodology is perfect. We do not get such enough number. We get, but the government support, if I have to say, is much larger. We are looking for a larger number, but we get much lesser. So this is a clear, I'm from inside, from the DST. I've been in DBT committees also. So the message I'm trying to say that unlike the Western world, if you compare in US and Australia, where number of good projects to the funding bodies is larger than the capacity of the funding bodies to fund. I've been there for about almost 12 years in like US and Australia, and you always find that the good projects are not being able to support because they have got only limitation of supporting, let's say 50 projects, and they could maybe 75 projects which are screened in, which are recommended for support, but lack of funding. In India, it's other way around. So that gives a kind of a clear invitation to all students and faculty members to improve the quality of their submissions to the DST, DBT, and all these MHR, Ministry of Education or UGC, where are, AICT, there are various bodies to have a good R&D proposals. Now, when I say R&D, that includes the innovation proposal also, that includes the fellowship also, that includes various kind of things, which these funding bodies in science ministries, they support. So that is a very clear thing. Rest assured that if you do good homework, make a good project, and if you are passionate, if you can convince the committee, then it's good for your career, it's good for your institution. Another point, I think, again, my friend Sanjeev has briefly touched is, and often I also come across, because I myself was a teacher for about 20 years before joining DST. Now, at least in India, especially in engineering colleges, where my interaction has been, often, and there is a question between teaching and research, because classically the colleges or even universities, We have compartmentalized that teaching is separate from research. And very often we see that if you are giving time to be a good teacher, you may not be a good researcher. Or if you require a good researcher, you may not be a good teacher. And because then how do I juggle around these two? Not only for the faculty members, but also sometimes the management is also confused that, okay, I'm having my BTech program. My job is to produce the BTech student, have all classes done with timetable. That's all. So even the management also get confused not to invest money on the research because that doesn't bring back, it's not visible. It's not visible in this short period of time. So it is at every level, at dean level, at professor level, at the vice chancellor level, at the management level, even up to certain extent, the government level also, especially in the education department, when you say, because teaching becomes the primary and research becomes the secondary, and if I can use the word optional, some professors wish to do research, they do. Some do not want to do, still they can survive without doing research or doing a very, very minimal research. Now, I must tell again with my own experience as well that again, as I was telling that the mechanical engineering, the shift has taken place in last 4 decades. Now, I wish to clearly tell all my friends here that the way the government, the way the education enterprise, the way education system is changing, the universities, everything is being ranked, everything is being measured. The time has come when, if you look at the global, all the top 500 universities, we measure teaching, but we give more emphasis on the research output. If you take the Harvard, MIT, Cambridge, they're known for the research outputs. Teaching is always assumed to be a good one. The reason is if you are a good researcher, it is assumed that you'll be a good teacher. And there is a evidence, there is a research paper, there are evidences that with good researcher labs, research professors, their students are achieving much higher heights than a pure teacher. Okay, so my message is very clear that whether you are a university, private sector or government sector, you are a vice chancellor, the management, as a university or as an institution, if you are looking for a long-term growth, no matter how good your teaching alone will not be sufficient to make you on the greater heights. You have to have the good research environment, good ecosystem, support for the teachers who do research, support for the students, PhD students who do the research, because research metrics will bring you the kind of a name, fame, grading, whether it is NAC accreditation or NBA accreditation. Research has been slowly getting more important and will get more important in future. And if you look at the Western world, no matter how good your teacher is, if you have got good publications and good grant, you are assured a tenure track job in US universities or even in Australia or the Western world. In India also, to reach a faculty position, let's say in IITs, it is a research which distinguish to entry point, even also promotion point. So this is very, very clear that earlier also pointed out, but I'm more vocal that because I can see the difference. 20 years back, I remember my teachers in engineering colleges, many of them were not PhDs and they were professors in 70s and 80s. MTech was something desirable. But in 2021, probably everyone needs to be on the research side, much more important. So such conferences like this conference, which has been organized, gives an opportunity to utilize all the people, especially students and teachers who are into the research, to have interaction, to make the teams and have a good quality research output. So I think these are my very, very, like initial, broad comments and my suggestions. And once again, I'm very happy that the organizers have received already 150 papers. And out of that, there has been some screening, and you have selected only 115 publications from the different streams of the mechanical engineering. And therefore, I think this is a good number in my opinion. Having 150 papers under these circumstances is a commendable job, I must say. And then after this, I think you are also planning to have publication in the journal paper, which will be published in the Journal of Engineering Research,
Yes,
which
sir.
has got citation. So this is pretty good. So these are all, some of my comments, and I wish good success to this conference, to the researchers, and a meaningful, day for everyone, organizers, researchers, the reviewers, and I wish you good luck. I wish good luck to the conference. I wish good luck to the MIT for, taking these steps, which I have told you, which are the right step to make the research trajectory of the institution in a research trajectory in a higher level order. Otherwise sometimes research is not given due credit. But I'm very happy for this, for the MIT to take this. And I was told that this is a regular practice. This is the first time that I'm able to attend your program. But I was listening that probably every year you have got these programs.
Yes,
So
sir.
thank you very much. Thank you very much. And I wish to interact in future also. Thank you. Bye.
Thank you very much, sir. And we also look forward for the opportunity to hear from you next year. I hope it would be conducted physically. And really, you presented your views enthusiastically, and your aura has added a charm to the occasion. Thank you very much, sir. And now I invite our Reverend Dean Academics, Dr. V.K. Sharma, to propose the vote of thanks. Welcome, sir.
Thank you, Meenakshi, for providing this opportunity to propose vote of thanks to such great personalities. First of all, I'm thankful to our Honorable Chairman, sir, who always and wholehearted supports for R&D activities along with the regular academic activities. Our Vice Chairman, sir, also support all these activities, and they himself take initiatives to organize such research and other activities. Now, I am thankful to Dr. Sanjay Mishra, sir, chief guest of this conference, who have spared time for us to motivate the people, researchers, young researchers, and particularly their motivational words regarding research, their suggestions about research, how a person, how a teacher, how a student can become a researcher. I am also thankful to Dr. S.K. Vashne from DST, who have spared the time to address the conference audience. I am also thankful to Chairman QCI, Pradeep Chaturvedi sir, for their kind words. I am thankful to Dr. Rajiv Sharma sir from DST for their always support in these conferences. I am also thankful to Dr. M.K. Pateria sir from DST, who always supported our academic system. I am also thankful to Dr. Amitanshu Patnaik from DRDO. They have supported our conference last year and this year also for their kind words. I am also thankful to keynote speakers, Professor P.K. Pandey from IIT Delhi and Professor H.C. Lim, PNU, South Korea, for their meaningful address to the participants. Last but not least, I am thankful to our Executive Director, Dr. Mayank Garg sir, for their wholehearted support to organize this conference. I am also thankful to our media friends, to organizing team, Dr. Bhupen Chauhan, Meenakshi, and other who have supported directly or indirectly. Thank you. Jai Hind, Jai Bharat.
Thank you very much, sir. We also feel privileged to have your supervision and backing with us at all times possible. And now I request everyone that this is the time to pay tribute to the nation. So can we all take a position to sing the national anthem?
Thank you.
Jai Hind. Well, ladies and gentlemen, let us take a break for tea and come back exactly after 15 minutes. And then we will move on to the first technical session. So everyone, let us take a tea break. Thank you.
Thank you, sir. Thank you.
So I will leave now. Bhupender ji, thank you.
Yes, sir.
I will leave now. Thank you.
Thank you, sir. Thank you. Thank you. Very kind, sir. Thank you. Thank you for time with us, sir. Thank you. Thank you, sir.
Thank you very much,
Thank you, sir.
Dr. Professor
भूपेंद्र जी, थैंक यू. कैन वी लीव नाउ?
Yes, sir. Yes, sir.
भूपेंद्र जी उस वक्त अनम्यूट नहीं हो पाया, इसलिए वी कुड नॉट से थैंक यू. अभी कर रहा हूँ कि थैंक यू.
सर, आपका नंद कुमार सर का और आशीष सिंह सर का आज प्राइज का भी वो अनाउंस हुआ था. तो
हाँ, यस यस, उसी वक्त ज्वाइन किया जब तक आपका फोन आ रहा था. तो थैंक यू फॉर द ये कंसिडरिंग अस फॉर द प्राइज. अब
थैंक यू सर. थैंक यू
अब
सर.
हम लोग
हाँ सर, सेशन चेयर पे आपका सपोर्ट चाहिए. सेशन चेयर में रहते हैं.
भरत, मैं कर देता हूँ ये.
हाँ
जी सर, आपका
भूपेंद्र
भी
जी, मैं बात करता हूँ आपसे फोन पे, राइट? अभी मैं थोड़ा सा. हाँ
ठीक है सर. ठीक है सर.
ओके प्रोफेसर भूपेंद्र सर.
हाँ जी सर. सर, आपने भी सेशन चेयर में भी रहना है सर. थोड़ा सा सपोर्ट सेशन चेयर के लिए भी चाहिए.
नहीं, certainly I am very much with you.
Thank you, sir. Thank you.
Thank you, sir.
Of course, it is your conference, a big conference, in the continuation, and also I am the very much part of the from the foundation of this your society to the conference to the journal.
Yes, sir.
And my good wishes, best wishes are with you and with your all the concerned persons.
Thank you, sir.
Thank you very much for considering.
My pleasure. So all attendees, after 10 minutes, we will resume as per our technical session. So this technical session is T here on Zoom, and rest of the 3 session is on this Google Meet ID shared with the respective authors. So please be there. So we will resume at this time. 12:15 we will resume again for this session, technical session. So be there. Any doubt if there, so please ask me or raise your hand, then I can unmute you, or your feedback or your any queries. Attendees, one hand is raised by one fellow. If you have anything to say, just let me know. Yes, sir. Krishna Kumar Jaiswal ji, yes, please.
हेलो.
Yes, sir. Yes, sir.
जी सर, गुड आफ्टरनून.
गुड आफ्टरनून सर.
सर, मेरा मेल नहीं आया है पेपर के रिगार्डिंग की कौन सी उसमें है पैनल.
आप अपना आईडी बताइए सर. आईडी बताइए, मैं आपको अभी.
जी सर, 1 मिनट में आपको बताता हूँ सर. AS.
हाँ जी सर.
21. 1 मिनट सर, वेट करिएगा. 21 सर, 01 और 07, यही तो था.
07. हाँ सर, ये सर अभी प्री लंच ही है. सो 12:15 बजे फर्स्ट सेशन में रहेगा सर आपका. और
जी सर.
ये सर सेशन ए, टेक्निकल सेशन ए है. इसमें
AS वाले सेशन में सर होगा ना, फर्स्ट सेशन में. जी सर.
हाँ सर, फर्स्ट प्री लंच वाले में सर.
जी सर. ओके सर.
ओके सर,
थैंक यू.
हेलो.
हाँ सर, बोलो.
सर, एक्चुअली इन कोरिया यहाँ पे इंटरनेट इनका वो है, सर्विस है. सो मे बी अराउंड 12:30 और 12:45 मतलब इंडिया टाइम के हिसाब से मे बी इनका थोड़ा सा वो हो जाए, डाउन हो जाए.
हाँ आप 12:15 पे अपना स्टार्ट कर सकते हैं 10 पे शुरू कर देना आप सर आप फर्स्ट वो कर लेंगे हम आपको और प्रीफरेंस के हिसाब से ऑर्डर आपका पहले कर देंगे सर
और सर इसमें मैं फॉर दैट टाइम बीइंग मैं इसमें जुड़ा रहूं कि शुड आई लॉग आउट एंड अगेन लॉग इन बैक
योर चॉइस सर योर चॉइस इफ यू आर ओके देन कीप ऑन
ठीक है
जॉइनिंग
सर I'll wait for you then sir
yes sir
okay sir
yes sir
हेलो
कृष्ण कुमार जायसवाल सर
सर कैन सर ये पूछ आई एम आस्किंग हाउ डू वी शेयर द स्क्रीन फॉर द प्रेजेंटेशन
देवांश श्रीवास्तव सर ये प्रेजेंटेशन का स्क्रीन हाँ हियर मैं आपको अभी अलाउ कर रहा हूँ हु कैन शेयर ऑल पैनलिस्ट ओनली होस्ट oh my god in Zoom just a minute okay I will as per the I will add you in this panelist and then you can share the screen
okay sir
during
thank
the
you sir
presentation I will add you in this panel as panelist and then you join the screen
okay sir thank you so much
yes Devansh Srivastav you want to say something hello
sir hello
yes sir
sir I got my answer you said you will add me in the panelist section during the presentation time
yes
thank you sir
any query you may raise the hand so that I can unmute you and then I can answer all the queries please let me know
भूपेंद्र जी विश्वास here
जी sir yes sir
so मैं recording I'm pausing the recording on YouTube
okay sir
so when should I start it
12:15 पे सर 12:10 पे शुरू कर देंगे हम लोग
12:10 पे start कर देंगे
जी सर
right sir
ठीक है
hello
yes sir
sir I have sent the PPT yesterday
okay
you
no problem
okay sir
so you just keep on presenting that time so here this is section D here with on Zoom ID so you join here as ICARI ME 5 6 I'm taking care of ME 5 6 7